and welcome to a new episode of Tech Unveiled. Did you know that most of the mobile traffic is generated indoor, and that users find indoor coverage twice as important as speed or battery lifetime? In this episode, we will unveil how to provide a true 5G experience indoor, while at the same time increase coverage and speed in a cost-efficient way for service providers. I'm Lena, and I will be your guide to unveil this topic. So please join me and let's go meet the experts. So with me here in the studio, I have Fredrik Tägt, 5G Indoor Solution Lead, and Peter Eriksson, Strategic Product Manager for Ericsson Radio Dot System. Welcome to Tech Unveiled.
Thank you very much.
Thank you.
So Peter, can you tell us why is it that indoor coverage has become so important lately?
Well, considering most buildings are receiving their indoor coverage from the outdoor network. And then we have at the same time a tremendous growth of data traffic. And according to statistics, 80% of that traffic is generated indoors. So when service provider plan to accommodate this traffic, they need to consider if they upgrade an outdoor network or if they build an in-building network to accommodate those needs.
You talked about this outside-in coverage, and today most of our networks are 4G. But Fredrik, now with 5G being deployed, what will be the main difference?
So the 4G networks cannot always cater for the capacity needs, and this is specifically true in hotspot areas, areas where you have a lot of people, like stadiums and arenas, commute hubs, train station and airports. And this is where 5G comes in, and specifically the 5G that is built on the 3.5 gigahertz. Here you get a lot more capacity. There's a lot of operators have gained access to this spectrum, and they're building the outer networks. If we compare the performance and capacity with the LTE network that is typically on a lower band, you have a 20 megahertz carrier there, typically, with 2 layers of data, 2x2 MIMO. So the end user performance here, we represented that with this box here. And if you hand me the other box here, Peter, thanks. The 5G mid-band based networks, they typically have a 100 megahertz carrier instead, where you have 4 layers of data, 4x4 MIMO. So there is at least 10 times improvement in the end user performance. And this is what we represented here in the boxes here. And the capacity then also increases a lot on this 5G mid-band spectrum.
So does that then mean that 5G will solve the indoor challenge with coverage, capacity and performance? What do you say, Peter?
Well, although we have this greater capacity and performance from the 5G network, it also suffers more from attenuation loss. And that means that the signal gets weaker as it propagates through the air, and in particular through building walls. If we take an example here, radio base station, an outdoor radio base station, and this would be the cell coverage of a 900 megahertz band, which is very commonly used in an older generation of the network. And then comparing that to a 3.5 gigahertz band, you see that the cell range is reduced by 50%. If you also would add concrete walls of a building like this one, you would have another 50% reduction. And as you see, both capacity and coverage will be reduced significantly. And that makes it very important for a service provider to really consider how to accommodate all this growing demand from indoor users, if they would expand on their external, the outdoor networks, or if they build a dedicated in-building networks for some of these hotspots where you have a lot of people using the mobile phones.
So if 5G alone is not the solution, then what are the solutions that service providers should look for when it comes to indoor coverage?
Yeah, so when it comes to dedicated indoor solutions, the solutions that have been used for many years are called distributed antenna systems, so-called DAS. Traditionally, these DAS have been built using these type of coax cables, as we have here. So this is used then to distribute the signal from the radio that you have in the basement, typically, up to the antenna point across the building then. On 5G midband, the attenuation that you have is too high on this one, so this becomes very unpractical. On top of that, you need more data layers, 4x4 MIMO, so you need 4 of these in parallel, basically. So they have introduced an active DAS, so-called, and then they replaced these ones with fiber cables instead to improve the distribution in the buildings. But the active DAS solutions are also coming with a lot more extra equipment then. So you have different cards and components for RF input into these solutions. Then you do different processing, combining and filtering of this, that you need dedicated equipment for that. Then you do conversion from RF to electrical to digital, and then from digital to optical. So you need optical transport cards to handle this distribution across the building. And then in the end of this chain, you also have a remote unit, a dedicated radio. And this is used then to convert back into the RF. So these solutions are not really practical. You get much more equipment and a lot higher CapEx due to this. And on top, you also increase the complexity in the solution. So you need dedicated operational system, O&M systems, and that also increases the cost on the OpEx part as well.
I agree with you. It sounds very complex and also costly. But what would then be an alternative solution? What do you say, Peter?
I have brought with me the Ericsson radio dot system. This is the industry leading in building solutions. It combines both a small form factor, low power consumption. It also has great performance. So you need fewer of these radio dots installed in the building to cover same capacity and coverage compared to a DAS system. It also can be installed using simple LAN cables. This is the same thing that you would have in your PC at home, for example. That makes installation much easier. And at the same time, it's really optimized for 5G. So this is prepared for the future. And in addition to that, we also have multi-operator support. So several operators can share the same in-building infrastructure, additionally reducing the total cost of ownership over time, and makes it much easier for the building owner as they don't have parallel systems in the building.
Well, that definitely sounds like the more cost-efficient solution. But do we have any concrete examples of that?
Yes, we have. We did a very detailed analysis where we compared an active DAS solutions with a radio dot solution. And the scenario we looked at was a 3.5 gigahertz 5G deployment. So it was a multi-operator solution, 3 operators having 100 megahertz each, 4x4 MIMO. And the conclusion there was very clear. The active DAS had between 30 to 50% higher CapEx requirement. And on top of that, you have the increased operational cost as well. So we now see, well, for the last year or so, we also see these conclusions from our operators. And they turn to us now even more than to buy this solution and deploy them. We've been deploying the LTE-based solution for many, many years. And now we see an increased interest here on the mid-band solutions on 5G then. So I think we have around 120 operators at least in 70 countries across the world deploying these solutions from all types of venues, from hotel, hospitals, airports, stadiums, etc. So yeah, there's a lot of interest now.
But that's impressive results. Thanks, Fredrik, and thank you, Peter, for sharing your expertise with us here today. And thank you all for joining us. And I hope you found it interesting. And should you want to learn more about 5G indoor coverage and solutions, then please read our blog. You find it on ericsson.com/techunveiled. And in our next Tech Unveil episode, we will talk about the power of 5G carrier aggregation. I hope to see you then. Thanks for watching, and bye for now.